So hello everyone, welcome back to my another video. So today we are going to discuss solutions of first three problems of weekly contest 372. So let's just jump into first question. So in this question we are given three strings s1, s2, s3, and we are allowed to delete the rightmost element in one operation if the length of the string is at least 2. So we cannot make a string empty. We have the length of the string must be at least 1 after performing certain number of operations. So we have to print minimum number of operations needed to perform such that all the three strings becomes equal. So for the first test, as you can see, if I delete last element of s1 and last element of s2, the s1 becomes ab, s2 becomes ab, and s3 is already ab. So you need two operations, we are able to make all the three strings equal. And if we see the second test case, uh, we have to remove all the elements of each string to make the all make the strings equal, that is equal to an empty string. But we don't want an empty string, so in this case it is impossible to make them equal. So the answer is -1. So let's see the solution for this question. So whenever we delete last last element, rightmost element, the string remaining is a prefix string. So if I remove c, the string remains ab. In second string, if there was d, if I remove this d, so this is again a prefix string. So the key observation is we want the longest prefix string which is common in all elements. For example, all strings. For example, if we have abcd, then a second string is abc, and third string is a b c d and e. To make this all strings equal, we must have this prefix abc, and to make this all strings equal to abc, we have to remove all the remaining elements. For example, in first string we have to remove d, and in last string we have to remove d and e. So we have to find the longest common prefix string which is common in all three strings, and all the remaining elements we have to delete. So no, the number of remaining elements is equal to the answer of the question. So uh, to implement this, I have initialized three pointers and calculated the longest common prefix string. And if if the for loop breaks at I equal to 0, that means there is no single prefix string which is common. So I will just return -1, and in int remaining I am storing all the remaining values. For first string it is equal to s1 dot length minus I. Similarly for second string is s2 dot length minus j, and same as third string, and I will just return the remainder. This was an easy question, so let's move on to second question. So in this question we are given a string of length n, and this string represents a uh, it is an binary string, and it represents the ball present at ith position. So 1 means the ball present is black, and 0 means it is white. So in each operation you can choose to adjust balls and swap them, and we have to make the string such that uh, for all black balls are to the right and all white balls are to the left. So for example, if this is 101, we have to final string after swapping it must be 011, and here if it is 100, final string must be 001. Similarly 011, then 011, and we have to return the minimum number of steps to group all those black balls to minimum number of steps to make such string. So let's just simulate solution and try to find observations. So let's just take an example as 1 0 1 0 1 1 0. So uh, we have to make all the zeros at the start and all the ones at the end. So first operation will be performed on this first index, and we swap this 0 with 1, so it becomes 0 1 1 0 1 1 0, and number of operations performed is 1. Now we have to make this 0 go at first position where um, before is a single 0. So after performing two operations it becomes 0 0 1 1 1 1 0, and here number of operations is 3 because first there was 1 and we performed two operation and total is 3 now. And now this last 0 we have to move it to this position, so it becomes 0 0 0 and 4 ones, and for this process it took 4 operations, so it is equal to, the final answer is 7. Now if you see the observation, if we are at ith index, the string which is previous string behind ith position is already sorted. So 0 already, all the zeros are at the start and all the ones are at the right. We just have to move the current 0 to the left of all the ones. So we can observe that the number of operations required to move this 0 before these all ones is equal to number of ones which are present before ith index. So for example, here we required two operations because there were two ones before this index. Here we in this uh, and it at this index we required four operations because there were four ones before this index. So this is basically the solution. So we have to find number of ones before that, before any index which where s of I is 0, and we have to add that in global answer. So this is also a pretty simple answer question. So I have declared a long answer and a counter to count the number of ones. If I found, and I will iterate through the string, and if s of I is 1 I will increment the counter, and if s of I is 0 I will just add the current counter to answer and return answer. So this was the solution for second question. And now third question, this was tougher than normal. Third question on Leetcode. So we'll just jump into the solution. So in this question, let's forget this n and try to solve it the question for just a and b, and n is just an additional condition. So let's just solve for a and b. Now let's say we have two numbers a and b such that its binary representation is uh, something like this. So this is a and this is b. So b is basically 4 and a is 8 plus 2 10. Now the multiplication of a and b, we have to do XOR in this question. So if we do XOR uh, on an on a bit where the bits the respective bits of both numbers are unequal, so we can swap them. If I do XOR with some such number such that the bit is set at this position, so the bits will become 0 1. sorry, it will remain 1 0, and if we do it with 0, it will become 0 1 0. So this is basically, if we do XOR on unequal bits, they becomes, we can keep it as it is or reverse them. And if we do it on equal bits, we can change it into 1 1. So if it is 0 0, I will put here 1, and the bits become 1 1. And if it is 1 1, I will just put here 0, and bits become 0 0. Now how can we maximize a into b after choosing a number, 4-bit number, such that a into b becomes maximum? So the key observation here is, we have to make one number, the absolute difference between two numbers, less, and uh, the number itself as big as possible. So if I just let's say first two bits we consider 1 0, because we can either swap them or just make keep them as it is, and there is no, both are eventually same case. And now as you can see, if we have 0 1, so if we make this one, this becomes 0, and if we make this 0, the this becomes 1. So the product of this type of representation will always be greater than this, because one number is greater, uh, one number is as great as possible, and second, the difference between both the numbers is as minimum as possible. So now, so we have to continue with this type of representation, and then again we have 1 0. So to make the difference as minimum as possible, the bigger number should be less, bigger numbers bit should be unset, and smaller number bit should be set. So 1 0 0 0 1 1, and again we have 0 0, so which we can just convert into 1 1, because the number should be also maximum. So if we convert these two numbers into this representation, we get maximum product. So this was the this is the one of the observations in which we can which is important. And we have an additional condition of n. So n basically means we can only perform operation, we can only change last n bits. So in this case, the maximum number of bits of any number are maximum number is 4, but we can only change last 3 bits. So this is an additional condition, so we have to consider that and make our make changes according to that. So let's see the solution for this question. So I'm just swapping numbers if b is greater than a. So after this, all a will be always be greater than b, and I'm initializing an x value, x string. So x represents binary representation of number x, which is asked to calculate in question. So now if s string s and s2 represents binary representation of number a and b. So if s of I and s2 of I are equal, so if s of I is 1, we have to make both of them 0, because XORing with 0, it will remain 1. And if it is not, then we have to check two conditions. We have to check one condition: if current I is greater than equal to 64 minus n. So this is just for checking if the bit is under the last n bits. If it is at under n bits, we can make it 1, or else we cannot change those bits. We have to just append 0 at in x. And then if they are unequal bits, so if they are unequal, first, if the ch value is -1, that means we have encountered these unequal bits for the first time. So it will be encountered S of I will be 1 and S2 of I will be 0 because I have swapped those values. A is always greater than B. So S of I will be equal to 1 and S2 of I will be equal to 0. So I will just append 0 because I will keep the eighth bit 1 and bth bit 0 and make ch equal to 1. Now if after that whenever we encounter an unequal bits, so if we again check the condition, if current index is within the last n bits, so if they are in last n bits, we have to work according to S2 now, because we have made changes previously according to A. Now we have to increase the value of B. So I will, if S2 is of I is equal to 0, I will append 1 and else I will append 0. And if the current index is not in the last n bits, we cannot do anything, so we just append 0. And finally I will convert this binary string into decimal and apply modular arithmetic and find the answer. So this is the solution of third question. uh, this is primarily based on bits and this key observation of multiplication. You can also observe this type of multiplication in this condition. So let's say we are given and a plus b equal to 10, and we have to find values of a and b such that a into b is maximum. So what are possible pairs? So 1 9 2 8 3 7 4 6 5 5 and just opposite of these pairs. So here when you try to find products, this is 9 18 27 36 uh, 21 24 and 25. So at the middle we found the maximum product. So this, the absolute difference between these two numbers is minimum and the number itself is maximum as possible. So this is the key observation which we had to find in this Xor question also. So I guess that's it for today. Thank you.